speed in under 2 seconds. So for the rest of the time that the car is travelling down the pit lane, it's travelling at a constant speed. We're going to calculate the total distance travelled through the pit lane using my actual velocity time graph of my Formula 1 lap from the pits. Let's see how I got on. So this is the actual velocity time graph of my Formula 1 lap through the pit lane. And in this question we need to calculate the total distance travelled in the first 6 seconds. Now we need to remember that the area under a velocity time graph is equal to the total distance travelled. So to calculate the total distance travelled in the first 6 seconds, we need to work out the area underneath this velocity time graph for the first 6 seconds. So the first thing that I'm going to do is go to the x-axis, which is time in seconds, and I'm going to go to 6 seconds, and I'm going to draw a vertical line up from the x-axis at 6 seconds until I get to the velocity time graph. And this area that I've now sectioned off, so the area underneath the velocity time graph up to 6 seconds, this area here is the area that I need to calculate. And this area under the velocity time graph will be equal to the total distance travelled. Now there are two different ways to calculate this area. Hopefully you've realised that this whole area here underneath the velocity time graph that we've sectioned off up to 6 seconds, this whole area is actually a trapezium. So we could work out this whole area in one go by using the formula for the area of a trapezium. So to calculate the area of any trapezium, we need to do a plus b in brackets multiplied by the height or divided by 2. And remember, on a trapezium, the parallel sides, which are these two sides, are a and b. And it doesn't matter which one we call a and b. So in this question, I'm going to call this side at the top of the trapezium A. And this side starts at 1.5 and it finishes at 6. So the distance A is the difference between 1.5 and 6. So here A would be 4.5. So we have 4.5. And B is the other parallel side. So B would be this side here. And this distance is 6. So we have 4.5 plus 6 in brackets, and we need to multiply that by h, which is the height. And this is the height of the trapezium. And the height of the trapezium is 22. So we're multiplying this by 22, and then we want to divide all of this by 2. And I do this on a calculator, and it equals 115.5. So the area of the trapezium, which is the area under the velocity time graph up until 6 seconds, is 115.5. And because the area under a velocity time graph is equal to the total distance travelled, this area is also the total distance travelled. Finally, I need to put some units on my answer. So to find out what units my total distance travelled is measured in, I need to look at the units for velocity. So the units of velocity is meters per second. So the distance part of these units is meters, which means that my total distance travelled will also be measured in meters. So the area under the velocity time graph up until 6 seconds, which is equal to the total distance travelled, is 115.5 meters. And this is my final answer. Now the second way to calculate the area under this velocity time graph is to split this shape into a triangle and a rectangle. So I take my ruler and I split this shape into a triangle and a rectangle, and then I can work out the area of the triangle and the area of the rectangle separately and then add these two areas together. So to calculate the area of a triangle, we need to do the base multiplied by the height or divided by 2. So the base of this triangle is from here to here.
So the base is 1.5. And we're multiplying it by the height of the triangle. And the height of the triangle is here. So the height of the triangle is 22. So we're multiplying by 22, and then I want to divide this answer by 2. Now I do this on a calculator, and it equals 16.5. So the area of the triangle is 16.5. Now we need to work out the area of this rectangle. And to calculate the area of any rectangle, we need to do the length multiplied by the width. So the length of this rectangle is from here to here. So the length is 22. So we need to do 22 multiplied by the width. And the width of the rectangle starts here and finishes here. So the width starts at 1.5 and finishes at 6. So the width is the difference between these two numbers. So the width is 4.5. Now I do this on a calculator and it equals 99. So the area of the rectangle is 99. Finally, to calculate the total area under the velocity time graph up until 6 seconds, we need to add these two numbers together. So we need to do 16.5 plus 99. And this equals 115.5, which is exactly the same answer that we got using the trapezium formula. Now remember, the area under a velocity time graph is equal to the total distance travelled, and because the velocity was measured in meters per second, the distance part of the velocity is in meters, which means that the total distance travelled will also be measured in meters. And this is my final answer.